A very good day. I am Mrs. Shaila, Assistant Professor, Department of Mathematics, SNS College of Engineering. Today I am here with the next set of lecture video. The topic that I have chosen is Statistical Quality Control. Before moving on to the problems of this, let me tell you what is Statistical Quality Control. Statistical Quality Control means the statistical tool used to monitor the quality of products, all types of products. It may be from a small piece of chocolate to a pencil, pen, the water bottles that we use, a table, chair. All these, the quality can be monitored using various statistical tools. The quality is based on two cases. One is common cause and the other one is attribute cause. So based on common cause, we call it as variable. Based on the variable cost, we have two types of quality controls. One is X bar chart, the other one is R chart. X bar chart means it is the mean chart. R chart is the range chart. I have taken a problem and I have taken a sample of 12 samples. Say I have considered the different types of pencils, 12 different types of pencils. In that, in each sample, the sample size is taken to be 5. Say suppose this sample one is Camden pencil. In that I have taken 5 pencils per sample. So from that 5 samples, this is the mean of those 5 and this gives the range. Range means highest value minus lowest value will give you the range. So similarly I have taken 12 different types of pencils and their mean value is already being calculated and the range value is being calculated. From this data, how do we go with the... Now, from the data, first let us form the X bar chart. For the X bar chart, the first thing that we need to calculate is the mean X bar. Mean X bar is nothing but summation of Xi divided by N. N means sample number. Here we have taken 12 samples. So N value is 12. Summation Xi is all the mean values added together. So summation Xi divided by N, from which we have got it as X bar as 136.75. Similarly range. Already we have the range value is being given. It is summation R. Add all the range values divided by N. N is sample number 12. From which we have got it as R bar is equal to 42.75. Now for this X bar chart, when we go for a quality control, first we need the average value. Here we call the average as central line, which is X bar. Then we have an upper limit and a lower limit. Always when there is a quality, when you go for quality check, there is a limit where it can exceed, it cannot exceed, and where it cannot decrease. So those two you call it as lower control limit and upper control limit. The formula for lower control limit is X bar minus A to R bar. And upper control limit, you call it as UCL. It is X bar plus A to R bar. Here A2 values. A2 value you get it from the control chart, statistical control chart. From that you have to get your A2 value for the sample size. Here the sample size is given to be 6. So for A2, sample size 6, we have written the value A2 is equal to 0.577. So substitute all your values in LCL. LCL is X bar minus A to R bar. I have got it to be LCL as 112.1. Similarly, UCL X bar plus A to R bar, you get it to be 161.44. Now, with all these data, we go for the graph replacing all the data values. Now, I have drawn the graph for X bar chart. Your x-axis and y-axis. X-axis we plot the sample number. Y-axis we plot the mean value. So sample number, I have 12 samples. So 12 samples being plotted. Sample mean, the least value, with that the range can be fixed by yourself. So I have taken a unit as 10 units. 110, 120, I have plotted up to 170. Now with this graphs, first you will have to plot the central line, lower control limit and the upper control limit. So I have drawn the line for lower control limit central line at 136.75, upper control line limit at 161.44. Now, after this, you have to plot all the mean values in this sample versus mean. So, I have plotted all the values. Now, if you check, all these points lie inside your upper control and lower control. Even if a single point lies outside, we decide it as out of control. Now, since all the points lie inside the range of upper control and lower control, we decide that all the mean values are in control. So, this mean chart is in control. Similarly, we can draw the chart for range value or sample number versus range. So, this is how we plot for mean chart. Thank you. Let me continue with the